With pleasure, I present you Dr. Sofra, neurophysiologist and clinical psychologist.
Okay. I will be talking about the fact that aging is actually not programmed. We don't have to age, and according to this, we don't have to die, but we do because of a certain process that keeps continuing even though it's not longer necessary. So there's different ages, different theories of the aging process, the programmed, the stochastic, and the quasi-programmed. And I'm going to be talking today about all of them. The programmed, unfortunately, basically gives us not much. It just says that we will just eventually die. The stochastic is about repair that happens, and the quasi-programmed has to do about what I'll be talking about right now. So there is a biological rigidity. You see this in everything. You see it in personality functioning. You see it in biological functioning. You see it in emotional rigidity and interpersonal rigidity. And the stability that brings it is a good thing. But however, the biological rigidity means that it functions continue, and the aimless continue without, even though we don't need them any longer. And of course, you can see the same thing with emotional rigidity, how it lacks flexibility, and how certain relationships, they can go on and on and on, and they're not very good for us. So basically, what the semi-programmed theories of aging say, that the brightest flame casts the darkest shadow. The very mechanisms that helped us enhance our development and make us be kind of more robust during development, these very mechanisms of the fittest, according to evolution, turn into aging and diseases later on in life. And specifically, it's the mTOR pathway. It's a signaling pathway. It has to do with signaling inside the body. A previous speaker was also talking about signaling. But basically, the TOR pathway starts from growth, enhances the growth, but at some point it turns around and it enhances aging. So basically, there are solutions, and the solutions are specific signals that can inhibit the TOR pathway. And PAAAMMI, for example, that inhibits the TOR pathway, also decelerates chronological aging. There is a number of investigators, there's a lot of research on this subject, and I can give you all the references if you're interested. And they demonstrate how the mTOR signaling pathway links development and aging, and cellular growth and senescence, robustness early in life, and diseases later in life. The semi-programmed theories of aging are also associated with a protein kinase called S6K1. And also, this component nutrient is responsive for the mTOR signaling pathway, and that leads in increased lifespan and resistance to age-related pathologies if it's depleted. And you can see here how also the PI3K, the phosphoinositide 3 kinases, also create ROS regeneration, which is the reactive oxidative species that affect our aging significantly. These are some solutions, again, how you can block and inhibit the PI3K in order to basically decrease the ROS production. And ROS production, oxygen is life, but oxygen is actually a free radical. It's the only stable free radical in nature that, because when you create energy, you go to the gym and you form energy. or any energy formation, it also, you basically burn a lot more glucose with oxygen. 24 molecules of ATP are produced out of burning glucose with oxygen versus only 4 when you have lactic acid and glucose. So oxygen is very important for energy, but however, it has a residue of ROS. And the reactive oxygen species create DNA lesions, and the DNA lesions basically create the telomere shortening and splinters, double strand breaks, and they lead to aging and disease. So ROIs are very damaging to our health. And there are repair pathways. For example, DNA methylation, there is DNA repair that we can do through signaling. There is histone modification. Histones are also something that can also, we can modify through signaling. And of course, chromatin. Chromatin is like a storing agent, takes all the DNA and stores it back to kind of, it's like a librarian kind of arranging the books back in its order kind of thing. So that's all of these aspects we can touch with signaling. Now, this is a very important aspect that proteins, when they are unfolded, they are useless to us. They have to be folded. Unfolded proteins lead to nonsense signals and they lead to aging. So as you can see here, for example, you see on the second on the nonsense mutation is just one letter that is wrong, that is incorrect. Instead of a C, there is a T. And the whole thing can change and create a disease, can create aging. It can even create cancer. So just very tiny mechanisms that we can target and repair that basically can age us and create a disease for us. And the question is, can you actually refold an unfolded protein? It's like saying, can you unboil an egg? Which seems quite impossible to most of you, but in fact, there is new studies that show that you can actually do unboil an egg by signaling molecules that basically you can try to refold the proteins again. And this is a press release from it's a Nobel Prize actually, 2015, that showed how the cells toolbox for DNA repair can actually unboil an egg, and that can be used eventually to target and heal cancer treatments, to be incorporated in cancer treatments. Now, is resonance energy, is it the resonance transfer, is it a theory, is the fact? Actually, it's a documented fact. As you can see here, with resonance, do you see the difference between the yellow parts, how they change? This is how they change. This is, obviously, it's a graphic, but you can see this under the microscope, how they can actually change via resonance. There are some more Nobel Prizes that show that actually cells do communicate, but they don't just communicate in proximity, they communicate from far away. So they have they travel with messages like the internet sends emails, and it reaches kind of all over the world in seconds. It's the same thing in our body. And this is the Nobel Prizes started from 1998, 1999, and of course 2015 I just spoke about. And what we see is that the neurons actually communicate like landlines, but astrocytes, which is other parts of neurons, they communicate by broadcasting signals, and the glial cells communicate like cell phones. So basically you can transmit messages. I'm going to show you in this video here. You see, these messages are very, very distant cells, and yet they reach these cells through, not through proximity, but through this broadcasting process that we're talking about. And this is more Nobel Prizes that show how there is a study that showed that they isolated cells inside the barrier, and these cells were able to actually communicate with the cells outside the barrier, even though there was a barrier, and they could not physically communicate with them. So there is communication in our bodies that happens no matter what, basically. So in programmed theories, we have no solution. We're destined to age and die. In stochastic, yes, we have a solution by declining and slowing aging via repair. And in quasi-programmed, we have a solution by basically shutting down certain pathways. So basically, we want to combine stochastic and quasi-programmed theories to enhance repair mechanisms and shut down certain mechanisms that continue aimlessly, resulting in aging and disease. And this is a technology and how proprietary energies below thermal noise, the ion channels of the cells for some reason open up. There's a mathematical formula that came out in 2008. And signals can enter, resonance signals can enter through the cells. And as you can see, you see how these signals can combine. They can kind of, because what happens with cells, they sort of bind to each other. That's how it happens all the time. Like human beings connect and they get married, it's the same thing with cells. And as you can see, they bind and then they basically enhance again the communications. And this is basically how the technology works. And this is some clinical evidence of repairing signaling pathways. This is the psoriatic lesion and the normal skin, and this is the before and after 10 treatments. This is the untreated and treated on a wound, very severe wound, accident wound. This gentleman was told he would never be able to move his hand or grow nails, but he did. And this is a herpes zoster before and after only 2 treatments. And this is a burn after 4 treatments. Now, in terms of inflammation is good for the young, but it's deleterious for the old. So, because it leads to chronic inflammation that leads to many diseases, including cardiovascular and many other diseases. Now, what causes inflammation? Trauma, toxicity, stress, high blood sugar, infections, no exercise. And that is going to cause cortisol increase. And the cortisol would increase your weight gain. And it would make your face look puffy. It will increase anxiety, it will increase mood swings, fatigue, acne. Basically, cortisol has deleterious effects on the skin. You make wrinkles, you have pigmentations, you get rosacea and acne. And a lot of studies, there's some studies that a few studies that show that with age, cortisol increases, whereas the other hormones like IGF-1, DSA, D3, estrogens, DHEA, all of those, and testosterone, they decrease, and progesterone. And we have now 8 hormones that are linked to weight gain. Growth hormone, the thyroid hormone, of course, insulin excess cortisol, serotonin imbalance, low testosterone. And unfortunately, you can talk about exercise, but when you reach 50, you're not going to be able to exercise to the point that you're going to remove your visceral fat. You're not going to get this, you're going to get this, because the visceral fat remains. Because if you really work as hard as it needs to remove your visceral fat, unfortunately, you're going to injure yourself. So, and the problem is that as we grow, we become more toxic. And the toxicity interferes with certain hormones like adiponectin and leptin, insulin, cortisol, of course, and adiponectin. And the interference with these hormones makes us more hungry. So we're starving. We cannot stop, we stop eating a little bit, the fat releases the toxins. The toxin makes us even more hungry, so it's impossible for us. So the more toxic we are, the more hungry we become. So we need detoxification is number one in weight loss. And the other problem with exercise is that cortisol increases while testosterone decreases. So with overtraining, you're increasing cortisol and you decrease testosterone. So you go back into this vicious circle of basically gaining weight and not being able to lose weight. And of course, the lactic acidosis makes your pH, the body pH, it upsets your body pH. So we do have a solution, and there's a few doctors around the world are working on this. Netherlands, India, Japan, Canada, myself. It was invented by Jerry Pollock, who also invented the pacemaker, and the United States, of course. And we've done a number of studies, and we saw visceral fat reduction experimentally with 24 subjects and 12 treatments at the very significant level. Muscle mass increase, increased concentrations of D3, increased concentrations of DHEA, increased concentrations of testosterone. Testosterone, the study was only 6 subjects. It was not 24. 24 is everything else. Jerry did a study on cortisol, and there was no significant increase of cortisol. That's very significant, and not significant increases in water content. So basically, the technology burns fat as an energy source to build muscle. And subjects reported a boost of energy because, of course, when you do this technology, you utilize oxygen, so you create a lot more energy. You don't use lactic acid that only creates 4 molecules of energy. This one creates 24 molecules of energy because the oxygen does that when it burns glucose. And that's it. Hopefully we're gonna find the cure. Thank you very much.
Thank you.
Thank you.